Hi, hello everyone. So this is the video dealing with section 2.3, polynomial functions and their graphs. And this is the second part of the topic, which deals with zeros and multiplicity of polynomial functions. Now, in order to eventually graph these polynomials, we need to know what these zeros and multiplicity of polynomial functions are. So the zeros is just another way that we call roots of a polynomial. Okay, so these roots or these zeros are just the points where the polynomial equals to zero. In other words, this is where we would solve this equation right here. We set the polynomial equal to zero, we solve the equation. We will find the x values that give the equation zero. Or in other words, if I have a graph of the polynomial, this is where they would cross the x-axis. So these are called the zeros. Now, so we have to find these values because we have to solve this equation as you see right here. Now, to find this equation, to find these zeros or these roots, we'll set the polynomial to zero, and the technique that we're going to use to find the zero or the roots are by the factoring techniques that we're familiar with from Math 119, for example. Right, so we're going to use GCF, the greatest common factor technique, or grouping, or factoring trinomials, or difference of squares, or in some cases, the sum and difference of cubes. Most often, we are going to use greatest common factor, grouping, factoring trinomials, or the difference of squares. Now, once we find the roots or the zeros of the polynomial, the next thing we need to know, and keep in mind our goal is to eventually graph the polynomial, is to determine the multiplicity of each zero or the root. Now, the multiplicity means that we can have a situation where the root is going to cross the x-axis or bounce back in the same direction on the x-axis. So the multiplicity can be either even or odd. And how do we determine that? So the root, if we find a root, or once we factor, our goal is to eventually factor the polynomial so that we have the individual factors being multiplied together equal to zero. And each factor is going to have, and you see, each factor is going to have an exponent attached to it. The exponent is going to be a number 1 or 2 or 3 or 4, any positive integer value. Okay? If the integer exponent is odd, we say that the root has an odd multiplicity. If the exponent is even, we say that the root has an even multiplicity. And why is that important? Well, here is the multiplicity of the roots, right? So if the zero has an even multiplicity, then the graph is going to touch the x-axis and turn around or bounce. So for example, if this value here, x equals 3, is a root, and I have an even multiplicity, the graph is either going to go this way, right? It's in the same direction and bounce back in the same direction, or from the negative side that way. So this is even multiplicity. If, on the other hand, the graph at 3 has an odd multiplicity, the function is going to behave this way, either coming from the negative and cross into the positive, or coming from the positive and cross into the negative. So this is odd multiplicity. So multiplicity, finding the roots and then determining the multiplicity helps us to determine the behavior of the polynomial at the particular root. And the multiplicity is always going to be 1 or greater because it's associated with the exponent on that root. Okay? So to find the root, we'll solve this equation. And then I will show you how to determine the multiplicity of the root, if it is even or odd. And then we'll know if the graph will look like a bounce in the same direction or a cross into the other side of the x-axis. All right, so here's an example of finding the zeros or roots and their multiplicity. Now, this is the easy way if the function can be given to us already in factored form. Okay, so I have three factors. I have the 1/2, I have the x plus 1, and I have the 2x minus 3 to the power of 2. So in this case, I would set each factor to 0, keeping in mind that 1/2 cannot be 0, so this is eliminated. This is not a possible root. I will set x plus 1 equals to 0, and we will set 2x minus 3 equals to 0. And then by the zero product rule, we'll solve for x, and we'll find each root. So here is the first factor set to 0. Obviously, the root is -1. And here is the second factor set equal to 0, and here is the second root. So we found the roots. So here is -1, and here is 3/2. Okay, so this graph here is the graph that software or a calculator did it. So this is the graph from a calculator, very likely the TI-84 calculator, but it's irrelevant right now. All that we're interested in knowing is the calculator graphed it for us, and we're interested in using the multiplicity to determine if the graph at the root is going to either cross or bounce back, meaning the multiplicity is either odd or even. Okay, so let's take a look at the roots. So we already found the roots. We already found the roots right here. These are the two roots. Now we go back to where they are in the polynomial. So this is the polynomial already in factor form. So this factor has an exponent of 1. There's an invisible 1 there, right? If the exponent is 1, we don't normally write it, but it's there. Now, a multiplicity of 1 means it's an odd multiplicity. Okay? And in the second case, in the second factor, 2x plus 3, which is this one, the multiplicity is 2. So this is an even multiplicity. All right? So the multiplicity has to do with the exponents associated with each factor. In the case of the odd multiplicity, as we said before, the graph is going to cross the x-axis, either from negative to positive, which is in this case, or positive to negative. And it did. The calculator shows that the function is crossing the root. In the case of the even multiplicity, the graph is going to bounce back in the same direction. So it's coming from the positive, and it's going back into the same direction, right? So it's either this way or it would be from negative to negative. In this case, it's in the positive side. So our calculator confirmed that our multiplicities correctly indicated the direction of the function in the -1 root and the 3/2 root. Perfect. So this is what we're supposed to do. We're supposed to set the polynomial equals to 0, and we are supposed to find the multiplicity of each root. Okay, solving the polynomial will be done by factoring, and the multiplicity of the roots is going to be determined by the exponent of each factor. All right, so now I have a couple of examples for us. And I have four examples. These are all very good because these are all the possibilities that we can have. We can have the first three cases. Um, I'm sorry, not the first three cases, the first two cases. In this case is maybe the most traditional case where the polynomial is already completely factored, as you can see. And the second case, the polynomials are not fully factored, they're in standard form, and we'll have to factor them according to the factoring techniques that we know and find the roots and find the multiplicities. So the first two cases are easier, obviously. We'll do them first. So it's similar to what we did before, all right? I have two factors. The 2 doesn't count because it's a constant factor. It cannot be a root. So we'll set each of these factors to 0, and we'll solve them for x. Very easy, right? Add 5 to both sides, and we get that one of the root or one of the zeros is 5, and minus 4 on both sides, and we get that the root here is minus 4. Now, again, the exponent to the x minus 5 factor is 1. So this is going to be an odd multiplicity. And the exponent on the x plus 4 factor is going to be 2. So this is an even multiplicity. So I am not graphing the polynomial right now, but if I were, here is my negative 4. And here is my positive 5. So on the positive 5, I have odd multiplicity, so the function is either going to cross from the bottom to the top or from the top to the bottom. And on the negative 4, it's even multiplicity, so the graph is going to bounce back either this way or that way. We don't know yet. In the next video, we'll find out the details, how to find the behavior, if it's one possibility or the other. Same thing for the next case, B. 3 cannot be a factor, so I will set each of these two to 0 and solve for x. So 3x plus 7 equals 0, and x minus 2 equals 0. This is very easy, right? Obviously. So one of the roots is 2, and in the second case, minus 7 on both sides. Divide everything by 3. And here's the other root. Okay, so I have two roots. Now, in the first case, again, I have odd multiplicity. And with the x minus 2 factor, I also have odd multiplicity. So if I were to graph again, right, so here is one of the roots, 2. And here is the minus 7/3. And in both cases, it's an odd multiplicity. So the graph is going to cross. We don't know in which direction yet, but it's going to cross at the root. Okay. So these are the two easy cases when the polynomial is already completely factored. Half the work is done for us. We don't have to worry about anything else. Now, in the cases C and D, we have to factor. So now we have to remember, the factoring techniques of GCF, grouping, trinomial, difference of squares. These are the main four. I don't think you're going to see sum and difference of cubes. Okay, so those you don't have to worry about. But the first four, which were, that was a main topic in Math 119, those have to be remembered. So we take a look at this polynomial, x cubed plus 4x squared plus 4x, and I can see that I can factor a GCF of x first. So I have x squared plus 4x plus 4. And then I have a trinomial that I have to factor. And you may remember how to factor trinomial. I need to find two numbers whose product is, this is the AC method, 1 times 4, and the sum that is equal to b, right? So the sum that is equal to b, the sum is also equal to 4. So the two choices for the product is either 2 and 2 or 4 and 1. And the only pair that can give me a sum of 4 is the 2 and 2. So I rewrite the middle term, okay, as a sum 2x plus 2x plus 4. And then I factor the x squared plus 2x plus 2x plus 4 using grouping, which it's you factor GCF twice. So out of the first group, so keep in mind, I am not reviewing GCF or grouping here. So I'm assuming that you remember how to do that, or if not, then you spend a few minutes reviewing GCF and grouping. So out of the first group, I factor x, I get x plus 2. And out of the second group, I factor 2, also get x plus 2. And then I can see that x plus 2 is a common factor. So I will factor x plus 2. And in the second pair, I also have x plus 2. Again, if you don't remember how to factor by GCF or grouping, you have to review that. That is extremely important for our course. Okay, so the original polynomial actually is fully factored as x plus 2, x plus 2. And now, to find the roots, we'll set each factor, including this x, right? We didn't do it before because it was a numerical factor, 2 and 3, but now it is at x, we have to set it to 0. So set x to 0, and you set x plus 2 to 0. These are identical. So what we are going to do is we have to write them in condensed form, right? Because these are identical factors. It's like the minus 2 root that we're going to find here appears twice. So this root is obviously 0. There's nothing for me to do here. And I solve the other one. And I get minus 2. So this is one root. This is another. And notice that the exponent here, there's an invisible 1. So this is odd multiplicity. And the exponent here is 2. So I have an even multiplicity. Okay. So if I were to graph, again, x equals 0 and x equals minus 2. At the minus 2, the graph would bounce back either from positive to positive or negative to negative. And at 0, it would cross either from negative to positive or positive to negative into the x-axis. Okay? So we found the roots, we found the multiplicities, and then when we're ready to graph, we know the behavior of the function through the roots. All right, very good. So one last question for us to do, which is similar to question C. And I'm going to have to try to factor this because it's not in fully factored form. And because it has 4 terms, I'm going to apply grouping. So I'm going to group the first 2 and group the second 2. So out of the first group, I can factor an x squared. I have x plus 7. The minus goes right here. Out of the second group, I factor a 4. Also get x plus 7. I see that x plus 7 is a common factor, so I factor that. I end up with x squared minus 4 as my second term. And then I realize that this is difference of squares. So as before, I factor that as x plus 2, x minus 2. So this is my polynomial fully factored. Now to find the roots, I set each factor to 0. X plus 7, X plus 2, and X minus 2. Solve each one. So minus 7 here, obviously. This is one root. Minus 2 here. And plus 2 here. Right, obviously this is supposed to be 2. So here are the roots. Now notice that all three cases, there's an invisible one here, there's an invisible one here, there's an invisible one here. Professor, how come this is not x plus 2 squared as before, right? As we had over here. Well, it's not x plus 2 squared because this is x plus 2 and this is x minus 2. These are two different factors. And sure enough, we got two different roots. One is negative, the other is positive. All of the multiplicities are, all of the exponents are odd, which means that all of the multiplicities are odd. Now, what does that mean? It means that when we were to graph, if we were ready to graph this, here is my minus 7. Here's my minus 2. And here is positive 2. All of the roots, the polynomial will cross either from bottom up or from up to bottom. Okay, in all three cases, through all the three roots, the polynomial is going to cross. Okay, and so this is going to be important in the next video when we talk about actually graphing these polynomials. All right, so in this section, we talked about how to find the roots of a polynomial by setting the equation f of x equals 0 and finding the roots through the known methods of factoring. And then we apply the multiplicity information to check the exponent of each factor. If the exponent is odd multiplicity, the graph is going to cross. If the multiplicity is even, like here, the graph is going to bounce back in the same direction.